Hi everyone, I'm Ginanti and I'm here would like to present my final report of the senior mechanical lab courses, which is about analysis of fluid, heat transfer and thermodynamics in Hairdryer. So now we move to the introduction. So why do we choose Hairdryer as our main object analysis here is because Hairdryer gives an excellent example of three systems at once. Example of an open thermodynamic system, fluid mechanics system, and also heat transfer. In hairdryer, there is moving of heat, work, and mass that crossing the control volume boundaries. Therefore, it is interesting to do analysis and experiment on hairdryer. And in this presentation, I will be explaining more detail about the experiment. However, not only in the laboratory session, but also I will be explaining starting from the planning stage, the experiment, and until the analysis. Now, this is about the preparation of the experiment. So, the whole process is starting from the brainstorming the ideas. So, this stage is basically a literature review on journal and research paper. And after doing some research, we come to adapt a paper by Robert Edward from the Pennsylvania State University 2005, and this work is exhibited in the American Society for Engineering Educational Annual Conference. And next stage is the planning stage. So we start to listing the component and buy them in the store. In this stage, we are considering to buy the stuff offline or only online via e-commerce. And we choose the store that provide the stuff and start to make the budgeting. At the end, we end up with buying the component in Shopee and in an offline store called Multilab Jogja. Next, we have the shipping. So in this process, there is shipping from store to house and from friend's house to house because some components are got from an offline store near my teammate's house. Therefore, it should be shipped to my house. And lastly, shipping from my house to the other teammate's house for passing the experiment. And the next stage is the experiment. So in this stage, basically we do unboxing to the component and setting up, also testing the component whether it works or not, and we also do the assembly, and lastly we do the experiment to collect the data. And lastly we have the analysis stage. So in this stage, basically we process the data and input it to the equation and use the theorem. And here are the phenomena that is observed. So hairdryer will be utilizing the electricity power, and the hairdryer will blows the hot air, and the hot air will flows into the environment by passing the pipe. So the phenomena from the electricity power to the hairdryer, this is the phenomena of thermodynamics that we can analyze by utilizing the first law of thermodynamics, and the phenomena of the hairdryer that blows the hot air and the hot air that flows into the environment by passing the pipe is the phenomena of fluid and heat transfer. So in this phenomena, we can observe the mass flow rate and the heat transfer by convection. And here are the components that is used during the experiment. So basically, we have six main components which are listed in this table, and the right is the estimated price that is got from a Shopee store and from Multilab Jogja. And lastly, for the pipe and masking tape, it is basically buy in an offline store, and in total we end up with uh, utilizing 950 rupiah to buy all the components. And this is the assembly of our system. So basically the hairdryer will be connected with the pipe, with the stainless steel pipe, and there will be 2 points, point 1 and point 2. In point 1 and point 2 we will make a hole, and in the hole we will uh, put in the pressure gauge to measure the pressure, and also the thermocouple and the anemometer to measure the temperature and the velocity. However, during our working, uh, our assembly by utilizing the analog pressure gauge as shown in here is not working. Therefore, we should choose another way to measure the pressure. And in this case, we are moving to change our assembly from assembly 1 by putting the pressure gauge to measure the pressure by using the bottle and flow. So we put a paper in the inlet of the hairdryer and a bottle at the top of it, and the flour will be put into the bottle until it is heavy enough to against the hot air that blows. Similar in point 2, so the hairdryer will be connect with the pipe first, and in the uh, outlet of the pipe it will be placed with the paper and the bottle. So we will do the same. We will put the flour into the bottle. And this is about the data collection and formula. So in point 1 and point 2, we will measure the temperature, velocity, and pressure. And we will be utilizing the formula of m dot for the fluid analysis, which is the mass flow rate. And in this experiment, we are utilizing the formula of m dot is equal to rho v a. So rho times v times a, in which rho can be got from the formula below, 21.33 times p per 9.5 time t plus 492. And for the heat transfer, we will be uh, analyzing by convection with the assumption of uniform surface temperature, constant properties, thin hollow cylinder, and there is no conduction and radiation that is occur. Therefore, our formula will be Q dot is equal to H times A times Ts or T surface minus TA. And lastly, for the thermodynamics analysis, we will apply the first law of thermodynamics, that the formula is listed below. Our assumption is that it is steady state, potential energy is negligible, and ideal gas. Therefore, we have 0 in the right side, and the G times Z both in inlet and outlet will be crossed. So we will analyze our equation will be simplified into V electric minus Q plus M dot in times H plus M dot in times V in square per 2 minus M dot out times H out plus M dot out times V out square plus 2. And here are our data collection and analysis. So from the experiment, we have velocity, temperature, and pressure in both inlet and outlet. For the velocity in meter per second, we have 21.7 in the inlet and 16.8 in the outlet. For the temperature, we have 112 in the inlet and 108 Celsius in the outlet. And for the pressure in inch per mercury, this is measured by teammates. The inlet will be 0.34 and in the outlet is 0.305. And from this data, we can directly find the rho utilizing the formula that have been mentioned. And from this result, we can input it again into the mass flow rate formula, which is rho times V times A, and we end up with mass flow rate in of 2.5 times 10 to the power of minus 4 kilogram per second, and mass flow rate out of 1.7 times 10 to the power of minus 4 kilogram per second. And for the analysis of heat transfer, we analyze it by convection with H is equal to 5 watt per meter square degree Celsius, and we got a result of 15.10 watt. And lastly, to analyze the thermodynamics by the first law of thermodynamics, we will needed to calculate the H. This H will be got from Cp times T, and in this case we have Cp is equal to 1.004 kilojoule per kilogram degree Celsius, and both for inlet and outlet is listed in here. Then this value will be inputted to the formula, and with the assumption of potential energy is negligible, we comes up with the result of V electric, or the electricity power, is equal to 5.43 watt. Wow, now we come to the problem analysis. So during our experiment, there's some problem that we face, and in this section we will analyze what makes our system does not work. So our first problem is the pressure gauge capacity. So our setup doesn't work with the analog pressure gauge because of the capacity. We we know that choosing the right capacity of pressure gauge is important for the reading, because a too large capacity might not measure the pressure that is too small. As the example, in our case, our capacity is 0 to 2.5 kPa and 0 to 10 kPa. However, after having a manual calculation, we comes up that the result of the pressure is no more than 100 PA. Therefore, our pressure gauge capacity is too big to measure our system. From this problem, we realize that pressure gauge capacity is one of the important things that should be considered, not only about pressure gauge but also the other instrument actually. So we have to consider the capacity so that our instrument can measure the system well. And our second problem is the measurement place. So each point might give different result, and the measurement place as specific as possible is important. As we can see, my result with the other two teammates shows a different result, and it might be so because our place to measure the temperature, velocity, and also the pressure itself is different. For example, measure the temperature in the middle of the in the middle of the circle with the in the surface of the circle is different. Therefore, it is important to set the same condition when measuring the data. So the same place as specific as possible is important in this case. And now we come to the conclusion. So our conclusion in here is that one system that shows the phenomena of thermodynamics, heat transfer, and fluid at once is the system of hairdryer. The hot air that flows is the phenomena of fluid, and the heat that out to the surrounding is a heat transfer phenomena. And from this data, we also can apply the first law of thermodynamics, which is the one application of thermodynamics for phenomena. And by applying the first law of thermodynamics, we can find the data of the electricity power that is needed in a hairdryer. In choosing every component in an experiment, we should consider not only the quality but also the capacity of the instrument, because every instrument have its limit, and we should take consider the capacity to measure the data. And we also noted that every measurement should also take place in the same place to give more specific data, more more detailed data as possible. And from this class, I also learned to be independently planning an experiment, starting from brainstorming, budgeting, problem solving, and analysis. Lastly, I will give feedback to the courses. So this courses gives a really great experiment on experimenting at home. So we are being encouraged to independently planning our own experiment, and we are encouraged to work along with the process, not only in the lab session but also the planning, the budgeting, or even the shipping, and how to cooperate with teammates to make a successful experiment. We also can freely discuss with the lecturer and gives our progress through the online meeting. So this online meeting and this online learning system does not limit us to learn in this course. And I think this is all for me. Thank you for listening to my presentation, and see you.